All right, we're going to work through chapter 4.4 today. So here is your bell work, and you can pause and kind of work through this bell work. Okay, hopefully you have paused and kind of worked through and got an idea of how to work through this problem here. And there are several things listed in this problem. So I give you this function up here, this logarithm, and I say, find the following: the parent function, transformations, domain, range, where it's increasing or decreasing, the asymptotes, the end behaviors, find the inverse, find the rate of change. So this is a ton of information for just this one equation here. So we'll start with the parent function. The parent function is log base 2 of x. We'll go through our HBAK so that we can get the graph. Okay, so this is kind of in a different form here. So if we move the 3 over here, so plus 3, that kind of gives it in the form that we've talked about. So h is going to go left 2. There is a negative in the b spot, so that would be over the y-axis. There is no a out front, and then your k out here will go up 3. So for log base 2 of x for that parent function, we're going to look at our xy table. So that would be 1/4, 1/2, 1, 2, and 4. We kind of went over how to get those. There's a pattern there. So -2, -1, 0, 1, and 2. And remember, this is the inverse of 2 to the x. So if I switch those x and y's, I get 2 to the x. So if we graph the parent function here, okay, so 1/4, -2, 1/2, -1, 1, 0, 2, 1, and 4, 2. Okay, here's our parent function. And now we'll just go through these movements to shift it. So we're going to go left 2, over the y-axis, and up 3. Okay, so there. So left 2, over the y-axis, this one stays, and then up 3. Left 2, over the y-axis, up 3. This is left 2, so 1, 2, over the y-axis, here, up 3. 1, 2, 3. And then left 2, 1, 2, over the y-axis, up 3. We also have this vertical asymptote that we would move as well. So right now it's at x equals 0. So we would go left 2, 1, 2, it'd be right here. Flip it over the y-axis, so it's right here, and then move it up 3, which you can't see it actually move up 3, but it is right here. So you have this logarithmic function right here. Okay, so the domain would be -infinity to +2 with a parenthesis because of that asymptote. Your range for any logarithm is all reals. So we've got parent function, we got transformations, we got domain and range. So is it increasing or decreasing? This thing is not increasing ever. It is decreasing on the interval of your domain. Okay, remember, decreasing has a negative slope, increasing would have a positive slope. If we look at our asymptote, we just talked about that. That would be x equals 2. That's this vertical line right here. Horizontal would be exponential. So we got increasing, decreasing. We got asymptotes. Okay, let's look at end behavior. So as x goes to, and we have right here from our domain, we have where x is going. So as x goes to -infinity, f of x goes to. So as x goes to the left here, where is this arrow going? Well, that's going to infinity. As x goes to 2, and it's actually going to 2 from the left, so we put a little negative sign up here. So as I go to 2 from the left, because I can't go to 2 from the right, okay, so as x goes to 2 from the left, your f of x goes to negative infinity. It's going down. Okay, so there's our in behavior. The inverse. Okay, so let me copy this equation down here so I have some more room. So it was log base 2 of negative x plus 2 plus 3. Log base 2 negative x plus 2 plus 3. Okay, so to find the inverse, this is going to equal y. To find the inverse, we switch x and y. So this is x equals log base 2 of negative y plus 2 plus 3. And then we solve for y. So we're going to subtract the 3. So we get x minus 3 equals log base 2 of negative y plus 2. In order to get out of the logarithmic form, we rewrite it in exponential. Okay, so that would be 2. If we kind of follow the circles, we start with our base. 2 to the answer equals this stuff in here. Okay, so that would be 2 to the x minus 3 equals negative y plus 2. Okay, so just rewrite it in exponential. Now we're going to subtract the 2. So that's 2 to the x minus 3, excuse me, minus 2 equals negative y. And then we just divide everything by negative 1. So that's negative 2 x minus 3 plus 2 equals f inverse of x. So here's our inverse. Okay. So we have inverse. Okay, now we need rate of change from negative 3 to 2. And that's the rate of change of your original function. So remember to find average rate of change. So change on negative 3 to 2. Okay, so we need f of 2 minus f of negative 3 over negative 3 minus 2. So if I find f of 2, okay, and this is our parent function here, and we, did we have f of 2 right here? Yeah, it was like 1.75. Again, you can plug that in to the actual, where's the function? Here's the function. You can plug that into the function. So we have log base 2 of negative x, or sorry, negative 2, because the x is negative, so negative positive 2, plus 2 minus 3, or plus 3. Okay, so that creates a problem because remember, we couldn't actually have 2. So I picked those numbers randomly and forgot about moving it right to. So we're going to change this to make it work. We're going to change this to a 1. Okay, let's change this to a 1. Okay, now we can work that. So if I change that to a 1, so that's log base 2 of negative 1, negative 1, or 1. Oh, I did this backwards. 1 minus negative 3. So that's a 4. F of 1, so log base 2 of negative 1 plus 2 plus 3 is 3 minus negative 3, which was just off my graph. So a negative 3 would be a positive 3. And that's about 5.3219. Okay, and then I'll subtract those and then divide by 4. So 3 minus 5.3219 divided by 4. If I can turn it into a fraction, that's nice because it is a kind of a slope, but I can't. So that would be negative 0.58 for that change. Okay, so lots of information that we can find there. This rate of change is kind of bringing something up from previous, and so is the inverse and in behavior. All right, so into chapter 4.4, we're talking about laws of logarithms. So our goal here is to use properties and laws of logs to rewrite, expand, and condense. Okay, so we did already have some properties or laws of logarithms and exponentials, but we're going to cover some more. So if we remember that we had something like log of base a of a to the x equals x. Okay, that was one. A to the log base a of x also equaled x. Okay, so those are two of logarithms that we have before or have had before. But today we're going to cover a couple really important ones. So these are our top 3. We're going to use these a lot in the next several lessons and all over the test. So if we have logarithms of the same base, okay, if we have logarithms of the same base, I'm adding them, I multiply a and b together. Okay, remember when we know that logarithms and exponential are very similar. So remember we had something like if you had a to the x, a to the b, or a to the y, when we had that, they had the same base and we add the exponents. So we'd have a x plus y. Okay, this is similar. This is kind of the same principle on this. Okay, if you're adding logarithms, you're going to multiply by what's in here. Also, if we had a over x or a to the x over a to the y, we subtracted those. So x minus y. Okay, so if I have subtraction here, I'm going to have division on the inside with logarithms. Okay, you don't do what it says. You don't add them, you don't subtract them inside the logarithm. And this here comes from the power to the power rule, in that if you have something raised to another thing, you multiply. So if I have this exponent up here, and this exponent could be on the inside or the outside of these parentheses, we can bring it out front. Okay, often you'll see it just written like this: log a to the c. And these aren't the same. These aren't the same a's. So just know that. It'll be written like this. And you still bring that exponent out front. Okay. Which we had that property on the last page. If we look here at this property, I could bring that x out front, and then log base a of a is 1. So x times 1 is just x. We also have what's called the change of base formula. And this formula used to be more important than it is today because calculators couldn't do different bases. They only did the common log and the natural log. Now we have the ability to do any kind of base. But what this does is it changes this base b to any other base I want. So for example, if I have log base 2 of x, or let's just put a number, let's say 7. And I can't necessarily calculate that into a calculator. I can change it to a different base that is in the calculator, say ln. So I could say ln of 7 over ln of 2. and we're changing the base to something that we can really work with. Sometimes you can do this to make things cancel, or to combine terms, or to do a bunch of other things with it. Okay, evaluate each expression. Okay, so remember we talked about with addition, in order to combine these logarithms, I'm going to multiply. So I have log base 4 of 2 times 32. And 2 times 32 is 64. So I have log base 4 of 64. Okay, and then I can change 64. I know 64 is 4 to the third. Okay, so now this log base 4 and this 4 are going to cancel, and this equals 3. Here I have subtraction. So with subtraction, we're going to divide. So we're going to have log base 2 of 80 over 5. Well, 80 divided by 5 is 16. So I have log base 2 of 16. And 16, I can rewrite 16 as 2 to the 4th. So then your log base 2 and your 2 cancel, and you have 4. Okay. Now this one, they give me a coefficient here out front. Remember, the coefficients can go to the exponent. So I have log of 8 to the negative 1/3. Okay, so we can rearrange this just a little bit. And that the negative exponent puts it on the bottom. And I have the 1/3, which is the cube root. So I have log of 1 over the cube root of 8. And notice there's no base here on this logarithm, so it is a 10 by default. The cube root of 8 is 2. So this is log base 10 of a half. And this is saying 10 to what power is a half? And we don't, like, that's not an integer number or a fraction or anything like that. So we would do this on the calculator, and we'd just say log of a half. And when you put log of a half, you're going to have to round it. So you get negative 0.301 for that one. Okay, so again, using laws of logarithms to expand the expression. So now these are condensed, and we want to expand them as much as we can. So here I see multiplication in here. So I have log of base 2, 6 plus log base 2 of x. And then I need to look again to see if I can kind of reduce these numbers into integers, or if I can bring down an exponent or anything like that. With this one, I can't, so I'm going to leave it right there. B, I have multiplication, but then I have exponents. So we're going to deal with the multiplication first. So I have log base 5 of x to the third plus log base y, log base 5 of y to the 6th. Okay, then these exponents here I can bring out front. So this would be 3 log base 5 of x plus 6 log base 5 of y. Again, you need to look to see if anything cancels or reduces, or if you can do anything more. In this case, we cannot, so it is finished. Here I have ln a times b divided by the third root of c. So that third root is an exponent, so we would have to deal with that. We have multiplication. We also have division, so we got a lot in this problem. So we're going to break up the division first, and we break up division with subtraction. So we have ln of ab minus ln of c to the 1/3. Now, you may be thinking, well, this would be a negative exponent, so why isn't this a negative 1/3? Well, it kind of is a negative 1/3 because of the subtraction. So this subtraction takes into account that this is on the bottom, which is why we subtract. Okay, so we can do a couple things here. We can break up this multiplication with addition. So we have ln of A plus ln of B. And then this 1/3 comes out front. So minus 1/3 ln C. And then nothing cancels or nothing reduces. So we have nothing else to do. Some things that may reduce would be like if I got down to an ln E, or if I got down to something like log base 2 of 4. Okay, this ln E would reduce to 1. Log base 2 of 4 would reduce to 2 because 2 squared is 4. So those are the kind of things you're looking at in order to reduce. Okay, a couple warnings here for this section is that if you are adding inside of the logarithm, you don't get to split that up with addition. Okay, remember these additions we actually multiply. So this would be log base A x y. You multiply. If you have two logarithms like this, you don't get to combine them into one. Okay, you can't do anything with this. This is change of base formula right here. But with this, remember, we subtract. So this would be log of 6 minus log of 2. Okay, this up here, right here, you can't do anything with that. Okay, that's it. Hopefully you can add those together, or maybe rewrite it in exponential to see what you can do. Here, okay, notice where these parentheses are. These parentheses are around the entire logarithm, which is a number, and they're taking that times itself 3 times. For this, the parentheses would just be around the x. Okay, so don't get that confused. Okay, so here, this will be our last one here, and we're going to use the laws to combine or condense each expression. Okay, so we notice first that we have some coefficients out front, so those go to the exponent. Okay, so we have log of x to the 3rd plus log, and that's the half power, so we're going to put in the square root of x plus 1. And then we have addition here, so that would mean to multiply, so log of x to the 3rd times radical x plus 1. And you can put all that in parentheses if you want. It's not necessary, though. Okay, so here it looks like we've got 3 terms, okay? A minus, so we're going to divide. So deal with your coefficients. So this would be ln s to the 3rd plus ln, that's a half power, so that's a square root of t. And then this would be, you can either just take the 4 or you can take the negative 4. It doesn't matter. If we take the negative 4, this would be plus ln t squared plus 1 to the minus 4. And remember that minus 4 goes on the bottom, so it's division. So the subtraction here is division, but also this negative exponent would be division. So here we would, if we combine all of this into 1, we have ln, okay, s to the 3rd goes on top. The square root of t goes on top because it was addition. But this negative 4 power goes on bottom as t squared plus 1 to the 4th. Remember, when you switch sides, it changes the sign of this exponent. So this is completely condensed. I can't reduce anything or do anything more. Okay, so we're going to stop there for day 1. Day 2, we'll pick up some word problems and the change of base formula. If you have questions, feel free to reach out.